Here we go. Day 5. So we're a little over a quarter done, actually. Remind students to check announcements. So we talked a little bit about data and we reviewed confidentiality, integrity, availability briefly. And we said, yeah, we know there's threats. What we're trying to do, and we've got the 3 different states of data, we're trying to make sure students are thinking about what they've already learned and how they can start applying it. So the threats, we know who, so we have a threat agent can carry it out. Are we vulnerable? And then what's our risk? Okay. I talked a little bit about risk levels. If that's very weird, some people are more willing to take a little more risk and some people are not. So we have kind of like levels, you know, and you have to match it up, obviously, maybe not obviously, but with your business. But your risk level might be a little bit different if you have a culture where people are concerned about security and taking care of things, and you feel like your employees understands the ethics behind what they can share, not share, and so forth. That would help a lot. I mentioned a couple extra things. Everybody should know how to write a script. And we talked a little bit about pen testing and becoming a pen tester. Penetration, and NIAC gets that done monthly. When Jim Deegan spoke, he talked about that. That one Friday at the end of the term. Some of you participated in that. We'll see about getting Jim back late this fall or next spring. We did some work with WPA2 Wi-Fi. I believe they called it Enterprise. Pre-shared keys. There was a guy like Phil and Bob, and you set up the access point. You set up their passwords, so you had a pre-shared key, encrypt, decrypt, and so forth. Key and an algorithm. The students looked up WPA3. A good place to look that up is the Wi-Fi Alliance. Okay, and then we looked at that wireless LAN and looked at the new features and how it went. Instead of a pre-shared key, it's using a public-private key combo. We talked a little bit about radius servers, 802.1x protocol for network access control. You know, how do we control people getting into an AP or connecting to a switch? We can authenticate them with a radius server. We can authenticate, authorize, and keep track of them. And these can be synced with directory services like Active Directory or whatever directory service you might be running. We demoed VPN, IPsec. I have a client, Global Protect. We actually demoed me from home connecting to NIAC, and then I went out to the internet and we talked about the difference between a split tunnel and not running a split tunnel when I went to Aaron. And the students noticed right away that I connected to NIAC, and then it was from NIAC is how I connected to the internet then. So they were controlling the traffic. Moving on. Talked a little bit about the history. Students looked up Alan Turing, Turing machine, the automatic machine, and his influence in World War II. So if you didn't look that up or you weren't here for class, that'd be worth 5 or 10 minutes. So we take plain text and convert it into ciphertext. Let me highlight that again. Plain text converted into ciphertext. How do we do that? We can encrypt it, so we can have an algorithm in combination with a key, and those two then can encrypt the information and decrypt it. We talked a little bit about key size and key space. You can look those up. And then managing the keys. since the algorithms are known, since the algorithms are known, managing the keys are very important. And if we take a look at symmetric, pre-shared key, okay, and asymmetric, public-private key combination. I mentioned briefly, we talked about a little example. Sent the public key here, encrypt with the public key, gets over here, we can decrypt it with the private key. It gets a little more complicated than that, but we'll look at that. Diffie-Hellman, RSA, as far as asymmetric, this whole idea of public-private. Encryption, there's different methods of encryption, block ciphers, steam ciphers. You encrypt the block, encrypt the bits as they move through. And it gets a little more complex than that, but we just need right now to be familiar with the terms. So, talked about all those key things in managing a key. Create a key, verify the key, figure out how to exchange the key, the lifetime of the key, revoke the key, etc., etc. Okay, I'm not sure I listed all of them there, but there's a number of things we need to do to manage the keys. Okay. Symmetric, we have a shared key. Asymmetric is often called public key. Works good for small amounts, but it's built upon difficult computational algorithms. We'll review that again tomorrow a little bit. More efficient, but a real problem exchanging the keys. So what you can do, you can use this to set up the keys for this. And we'll touch more on that later on. Talked about VPNs, IPsec. IPsec is really a framework to set all of this stuff up here. Stuff like internet key exchange. Are you going to use secured socket, or are you going to use transport layer security? Secured shell. This is really what people are using now, even though they still refer to it as SSL. Pretty good privacy. We can demo some of that stuff in the Linux boxes. So then, we talked about IPsec using this concept. It's a whole framework. You set up security associations, how you're going to encrypt, and etc., before you exchange the traffic. And you look for interesting traffic in order to exchange that. More on that later on. We can go transport mode, where you're encrypting the payload and still see the IP, or we can go tunnel mode, in which you encrypt the entire packet and have to add a new header. Left. We talked about, very briefly, we talked about physical controls. You can look up all the different physical controls, how you can protect your data centers or your equipment, your computers, and all that. And we talked a little bit about logic controls, what are they doing currently, fobs, smart cards, biometrics, etc. All these different things. Then we talked about access models. Is it mandatory? What you can access, discretionary, the owner can decide who can access what. Is it based on a role, or do we have some type of rules, like an access control list? Access control, typically then determined by the administration. They create policies and procedures. We need to classify the data. People need to be trained. In fact, the whole thing rests upon people. We talked about culture and so forth. Oh, we did, if you do a search on Light Edge in Kansas City, they have a little video that talks about some of the physical and logical type controls that they do to keep people out of their subtropolis data center. Somehow we need to identify before we can authorize. Once we can identify, then we can authorize what they can do, as a group or whatever way you might be doing that. What they can do to objects. Objects can be files, etc., etc. Things can be fit into objects. The curriculum doesn't mention this quite at this point, but these are a couple terms. Least privilege, more or less, don't give anybody any more privilege than they actually need. So you got to be able to know what data and how it's classified, and then limit who can see what to avoid somebody deleting something they shouldn't even have access to. As an example, zero trust. We used to have, the concept years ago. If you had this really strong firewall, okay. Yeah, let me go here. Really strong firewall. People couldn't get in. Well, nowadays people get in. They either phishing or whatever, or more sophisticated ways to get in. So we have to worry about, once they're in, moving what we would call east-west within your data center. So they have this zero trust. You don't trust anything. You're going to check who it is, what app they're running, and what content they're accessing, and it has to be verified all the time. So some people don't like the term zero trust. I don't mind it, but anyway, more on that later. Accountability, keeping track of who did what, to allow us to audit the information, maybe for billing. Why do we have an error? Who was working with what when this went wrong? Or we get some kind of breach maybe, and we have to do investigation. We want to look at applying these ideas to our Linux secured situation. The whole gamut of who can see what. Giving some privileges to people to do different things. We'll talk more about that actually tomorrow. AAA, policy, guidelines, procedures. Yeah, somewhere in an administrative role, people have to decide who can do what and keep track of it. Oh, curriculum mentions a few other controls and data masking. You can look at that in the curriculum. That is it.